Hello and welcome to Crash Course AP Physics 1. This is a new unit, Rotational Dynamics. And in this is the first topic, Rotational Kinematics. So what are the variables used in rotational motion that we will discuss? Let's first discuss about the angular displacement. So in the linear displacement, when the object moves from this point to another point, S is your displacement. So the distance covered is the displacement. Whereas when the body is doing the rotational motion, so each particle would be covering different distance. So it is not possible to frame the equation with respect to that. But if we observe, theta or the angle would be same for all the particles on this axis. So in a time t, how much angle it moved, that is your angular displacement. Angular displacement theta in radian is equal to arc length upon radius, or I can say theta is equal to s upon r. R is the radius and s is the arc length or the distance covered. And that's why I can write from this that S is equal to r theta. So the linear distance covered by a particle doing the rotational motion would be equal to r into theta. And this theta should be in radian. SI unit is radian. Next is the angular velocity. Like in the one-dimensional kinematics, object when it is moving and covering distance s in time t, that gives the ratio of it gives the your velocity, or the distance, change in distance upon change in time, that gives the velocity. Similarly, in angular motion also, angular velocity is equal to change in the displacement with the elapsed time. So d theta upon dt would give the omega. So from the previous slide we have seen S is equal to r theta. I just substitute this in this term. So V is equal to dr theta upon dt. So r means radius is not changing with time, only theta is changing with time. So I can write V is equal to r d theta upon dt, and this is your omega. So a new term I got, V is equal to r omega. So linear velocity is equal to r times of angular velocity. Let's see angular acceleration. So in linear motion, a is equal to change in velocity upon change in time. And in rotational motion, average angular acceleration, which is represented by alpha, is equal to change in angular velocity, which is d omega upon d time. When there is change in the magnitude of velocity, that produces the angular acceleration. We can write v is equal to r omega. Just substitute this in this equation. So it would be a is equal to d upon dt into r omega. So r is constant with respect to time. So I can write r into d omega upon dt, and d omega upon dt is your alpha. So it is r alpha. So from this we know that a is equal to r into alpha. This is tangential acceleration. This is tangential acceleration, or which is acting towards a tangent. Two accelerations act in the circular motion. One is towards the center, which we call that as centripetal acceleration. But I am not talking about this. I am talking about the tangential acceleration, which is AT. Now let's learn about the equations, constant acceleration kinetic equations in linear motion, and what are these equations in rotational motions. So in linear motion, we have three equations of motion. So v is equal to u plus at, s is equal to ut plus half at square. This is second one, and the third one is v square is equal to u square plus 2as. So from the previous slides we learned that s is equal to r theta, v is equal to r omega, and at is equal to r alpha. So if we substitute this equation in the linear motion equation, we get rotational motion equation. The first equation would become omega final is equal to omega initial plus alpha into t. The second equation would be theta is equal to omega initial into time plus half into alpha t square. And the third equation would be final omega square is equal to initial omega square plus 2 alpha theta. So these are the three equations in rotational kinetics. Let's solve some of the example. A mechanical wheel initially at rest on the floor began rolling forward with an angular acceleration of 2 pi radian per second square. If the wheel has the radius of 2 meter, what is the distance does it cover in 3 seconds? Initially it is rest, so omega initial is equal to 0, and the angular acceleration is given to us, which is 2 pi radian per second square. And the radius of the wheel is 2 meter. So in 3 seconds, how much distance, linear distance it would cover? So theta, how much it would cover? So we will use the second equation. Theta is equal to omega it plus half alpha into t square. So initial omega is 0. So it would be 0. Theta is equal to half alpha. Alpha is 2 pi and time is 3 second square of it. And when you solve it, it would be 9 pi theta. So it would be in radian, right? Now convert radian to meter. So we know that in one rotation, the angle covered or the theta covered is 2 pi radian, or I can say in 2 pi r meter, because it is the circumference of the circle. In one rotation, the whole circumference would be equal to the linear distance covered, would be covered in theta 2 pi radian. So in 9 pi radian, it would cover 2 pi r upon 2 pi into 9 pi. So when you solve it, it would be 9 pi r. This is the linear distance covered. So 9 pi into radius is equal to 2 meters, so it would be 18 pi meter. This distance would be covered. D is the correct option. Now let's see another example. A wheel started from rest undergoes a constant angular oscillation of 2.5 radian per second square. After rotating through the angle of 10 radian, what is the wheel's final angular velocity? So we have to find final angular velocity. Initially it is given at 0. Alpha is given to us, which is 2.5 radian per second square, and theta is the distance it covered, which is equal to 10 radian. To find the final angular velocity, we can use third equation, which says omega final square is equal to omega initial square plus 2 alpha theta. So it would be 0, and omega final square would be equal to 2 into 2.5 into theta. Theta is 10 radian. When you solve it, it would be 50 root omega final is 50 root 50 radian per second. So omega final, I can write it as 5 root 2 radian per second. How much time does it take to rotate through 10 radians? So I can use the first equation, which says omega final is equal to omega initial plus alpha into t. So I is 0, omega final is 5 root 2 is equal to 2.5 into t. Time would be 5 root 2 upon 2.5. So it would be 2 into root 2 seconds. Let's solve the next question, which says a particle is starting from rest, moves in a circle of radius r, and attains the velocity of v0 meter per second in nth round. Its angular acceleration would be. So we have to find the alpha. What is given to us? Omega initial is 0. And the final velocity is given to us. So omega final would be equal to, because we know the relation v is equal to r omega. So I can write omega final would be equal to v0 upon r. And it is achieved in nth round. So in the first round, if you say 2 pi radian distance would be covered. In second round, it would be 2 into 2 pi radian distance would be covered. In third round, it would be 3 into 2 pi radian distance would be covered. So if in the nth round, how much distance, angular distance would be covered? It would be n into 2 pi radian. So we have omega initial, omega final, and we have theta, which is 2 pi n. So we can use the third equation to find the alpha. So third equation says that omega final square, omega initial square plus 2 alpha theta. This would be v0 square upon r square is equal to, initial is 0, so it would be 0 plus 2 alpha theta would be 2 pi n. So when you solve it, it would be alpha would be equal to v0 square upon 4 pi n into r square. This is your alpha. So this is your angular oscillation. D is the correct option. That's all from my side. Hope you like the video. So like it, comment it and subscribe my channel. If you have any queries regarding this video or you want private tuition from me, then you can mail me on foster.physics@gmail.com. So if you are planning to take course for AP Physics 1, AP Physics 2 or C mechanics part or electricity or magnetism, then scan this and WhatsApp me to get the heavy discount now.